Hello, everyone. I'm Dan Welton, the editor-in-chief for the Facilities Market of Trade Press Media Group. Our brands include healthcarefacilitiestoday.com, Building Operating Management Magazine, facilitiesnet.com, among other facility brands you are probably familiar with. Thank you for joining today's webcast. Learn how to manage, track, and resolve electrical asset and network issues anytime, anywhere. Our presenters today are Alfredo Arola and Amy Pavel. Alfredo joined Schneider Electric in 2011 as applications engineer for energy management and control systems with a focus in oil and gas automation projects. Since 2016, Alfredo has been part of the leadership team developing and commercializing Schneider's cloud predictive analytics solutions for electrical distribution equipment and products. Amy has a passion for healthcare since supporting the segment at the start of 2020 and witnessing the dynamic role facilities played during the pandemic. She has been with Schneider Electric for 10 years, managing strategic partners and customers in the digital energy, secure power, and services divisions. Our webcast today has learning objectives that include discuss the digitization of critical electrical infrastructure, learn how to use data to achieve mission-critical outcomes, and review why technology alone is not enough in the path to true digital transformation. Now, before we get started with the webcast, I'd like to cover just a few details about today's event. We do encourage audience questions throughout the webcast, and to submit those questions, please navigate to the Q&A button at the bottom of the screen and type in your questions. Our presenters will answer as many questions as time permits. At the conclusion of today's webcast, you'll receive a PDF copy of today's presentation slides. You will also receive a link to a brief online assessment, and upon successful completion of this assessment, you will receive your CEU certificate. Today's webcast will also be archived at healthcarefacilitiestoday.com/webcast. And with that, I'm going to turn it over to Amy.
Yep, thanks, Dan. So to start off, I'd like to do a quick overview on some known and new trends that are shaping the future of the healthcare industry. Alfredo, do you mind? Oh, there we go. So first, there is a surge in aging population, which is doing one of two things. First, it will increase the demand on health services. And not only that, but the individuals that are making decisions on behalf of that aging population are from a younger generation and will have new and digital expectations around how they interact with healthcare systems. In addition, we've probably heard of the silver exodus, where people over the age of 50 are retiring at greater amounts due to the pandemic. So for facility maintenance workers, what that means is that what's going with them is that trades knowledge and years of experience on the equipment. So we are needing to rely on IoT and utilizing the data better coming from devices to quickly train the green workforce. Next, there is a staggering sort. Can you hear me? Oh, yeah. A staggering shortage of healthcare workers, and by 2035, the world will be short 12.9 million healthcare professionals. So in response, the healthcare industry is turning to digitized, automated solutions to find that balance between that growing population that requires care and the diminishing population qualified to provide it. Then we've all seen in the news the increasing security threats on healthcare systems. Cyber attacks are becoming more prevalent across the industry, and it's threatening patient and staff safety. And also just disrupting normal business operations, which are critical in these days. And then countries around the globe, and specifically in the US, are adopting net zero ambitions. Healthcare systems are large contributors to national carbon footprints due to their water and energy intensive practices. And healthcare systems will need to adapt to drive down emissions and help achieve carbon neutrality. Lastly, there's continued focus on delivering patient-centric care that hospitals are now being monitored on and are expected to increase patient experience and elevate quality of care. The key to that is designing buildings that are responsive to people, staff, and patients within it. A digital infrastructure drives a better patient experience and places more control in the patients to promote a healing environment. So with that, I'd like to share a few insights with you in our global current situation and the challenges we're facing. The luxury of time for many of us, particularly working in operations, seems to have disappeared completely through the pandemic. Businesses that once mapped digital strategies over 2, 3, 5-year phases had to scale their digitization initiatives in a matter of days or weeks. So we saw the pandemic accelerate the pace of digital transformation, and it really provided a glimpse into a future world where digital has become central to every aspect of our business, not just operations. And for many individuals and companies, it actually pushed people up the adoption curve almost overnight. What this means to you as an operator is that digital tools, software, and services, including analytics, are enabling unprecedented insight and access to the behavior and condition of business. So to talk more about those details, I'm going to pass it over to Alfredo to get into the weeds. Alfredo.
Absolutely. Thanks so much, Amy. First of all, before I begin, I want to thank everyone for being here. Time is our most precious resource. And I know that taking 45 minutes, 50 minutes to come and listen to us, we're going to try to make it worth your while. So I've spent quite a bit of time in the digital industry, maybe a little more on the industrial side of things, but in my last role, working with our predictive digital technologies, I had the chance to work with several other customers in other industries in North America, as well as in Mexico, South America, etc. Right? So I got the privilege to really widen my view of the world and the different industries and what the priority is, right, for all these different industries, including healthcare. So some of you might have heard that Schneider launched a strategy a few years ago called EcoStructure, right? And so I'm going to start right there because I think that's the backbone, that's the fundamentals of everything that we want to do for our customers and for the world, right? So here we go. EcoStructure, it's an open cybersecurity platform that goes across all different domains. So the different domains is EcoStructure building, EcoStructure power, which is where we're focusing on today, EcoStructure IT, machine, plant, grid, etc. Right? All of these different domains that you see here in the bottom speak for what Schneider sells at 3 different levels, and the deliverables that we have at 3 different levels. Right? So these 3 levels is what is marked here on the left-hand side. And so we start with what we call connected products. And connected products is nothing else than all those devices that are on the field and that we are familiar with. It may be sensors, it may be instrumentation. We're talking about the power domain. We're talking about maybe circuit breakers, protection relays. We're talking about the IT domain. We're talking about UPSs, for example, right? So it's everything that is on the field that has some sort of intelligence, right? And it is connected or is connectable, right? So that we can monitor it. And so that takes us into the other layer. The second layer that Schneider designed or thought about is edge control. And edge control is nothing else than your traditional on-premise or now, in some instances, on the cloud software, right? So it's a means to be able to bring all that data that our devices are producing and be able to monitor it, right? Be able to grab information, start analyzing it for different purposes, right? Why did these disconnect? Why did I have a breaker that tripped? Or why is my generator acting up? And so be able to look at that data without being in front of the equipment and making sense of that data at a local level, right? All these 2 pieces, if you think about it, if you've been in the industry long enough, these 2 pieces have existed for years. I think the first time we saw a microprocessor relay or a sensor that you're able to install in the field was probably, I don't know, 10, 15, 20 years ago. When we started talking about monitoring software, electrical management or electrical and power monitoring software, again, we probably can date it back to 15, 20, 25 years ago, right? And so the innovation there has really happened in the sense of adding speed to the communication. So our devices are able to communicate more efficiently, more reliably, that opens some doors, right? But innovation in that sense has stayed right there. And then when we talk about analytics and services, the evolution in computing power and the surgence of cloud services, right? And how cheap storage is now in the cloud, it enabled a different layer of technology where we can now take selected data, bring it to the cloud, whether it is for on-premise, quote unquote, monitoring software or for other higher level analytics, and use it to provide further value, right? So this is the vision that Schneider has been painting for quite a few years. And it also puts an order to the things that you see even in your infrastructure. You have products on the field, you have a ways of monitoring it, and you want to analyze that data, right? So it's very natural. And of course, across all of it all, it's cybersecurity, right? So it's also a key component, and let's say it's designed by default in everything that Schneider is doing in all these three different layers of technology, right? Now, we also have to talk about the change that Schneider has been doing, okay? So Schneider lately, in what we call our digital services, we talk about a unified operating model. And if you look at the Maslow pyramid that's here on the left-hand side, right, we're starting with the basics. We're starting with compliance and safety. We're going to reliability and resiliency. And ultimately, we want to be sustainable, right? That's the goal that everyone has in mind lately, right? And really around this ambition, right, of going from the basics to sustainability. For us, it is all surrounded around connectivity, data, and of course, cybersecurity, right? The funny thing is that today, Schneider is pushing, and other companies are pushing this change, right? But in many cases, we see that some of the aspects of this pyramid are a little inverted. So we're also in the business of helping our customers walk the path to correctly, let's say, put the priorities in order and achieve these outcomes, right, that we want to deliver for our customers or clients. What we do in the Schneider a few years ago, we realized that digital is the way of the future, right? Digital is the way in which we're going to correctly utilize data, connect things, make sense of the information, really change and shape the lives that we're living, right? So Schneider, about 2-3 years ago, we created a division within services that is called digital services. And digital services touches everything that we do in Schneider around power, industry services, secure power services for data center aspects and all of that, right? And power system services. And so we're really touching and digitizing all these different aspects and really unifying that model where everything that we do, digital is in our DNA and is part of what we want to deliver for our customers to deliver the better outcomes, right? And in the bottom, you can see some of the logos that, just a few of them, because there are many more, that have really been walking with Schneider in this digital journey, right? Now, when we talk about digital transformation, which is what we want to help our customers, what we want to deliver to our customers, and we want to help them walk in digital transformation. If you research on the internet, just digital transformation in general, you will see that digital transformation is not only about the technology, and people get very hung up on the technology piece. I have a fantastic piece of software, I have a fantastic sensor or a fantastic, system that is telling me the health of my generator. And so we get very hung up on the technology, the software, the hardware, this intelligence and all of that. But then we forgot about two key aspects of the digital transformation process. And those two key aspects are the people and the processes, right? And to simplify, we might be able to deliver, a great piece of technology, a piece of software, like what we're going to talk about here today and some of the examples that I'm going to give you. But if we deliver that to our clients and internally our clients don't have the necessary understanding of the tools they have, the training to utilize them correctly, the identifying the processes that they need to change in order to be able to drive actions out of the information that they are receiving. And then how that changes their day-to-day processes, their day-to-day operation, their way of, let's put it in very simple terms, the habits and the processes that they have in order to do maintenance or in order to react to an impending failure, right? Then we really haven't changed anything. The information that technology provides ends up being underutilized. And to exemplify this, there's a particular example that I always like to give, and with this I will move on. It's most of us in this day and time, we have a personal assistant at home, something like Alexa or Google, right? Or you carry a fancy watch, an Apple Watch, right? And we buy this technology because of the promise of what technology is giving us, right? A watch that can detect atrial fibrillation, great. A personal assistant at home that can do a million things. But if I run a poll here and I say, hey, how many of you, what is the number one use or the number 1 and 2 uses that people give to Alexa or Google personal assistants at home? And typically the answer to that will be to either play music or to set a timer, right? And so basically we have a very fancy, very expensive speaker that could have many other purposes and uses, but we're underusing it, underutilizing it, because nobody has really, taught us how to use it or gave us a process to how to transform our habits and ways of exploiting that technology. And so that really translates also into other aspects. And this is why Schneider designed the services that we design and the way we design them. And so we'll go in a little bit into that, right? So I'll talk about what we call our EcoStruxure advisory services, which are really at the top. If you remember the EcoStruxure pyramid, right, or the EcoStruxure stack, right? We have connected products, we have a software or edge devices that capture that data, and then we have the analytical services. And so our EcoStruxure advisory services are in that third layer, where we are grabbing data from the equipment on the field, and then we're making sense of that data to provide a certain value, okay? So if for our advisory services, if I were to give you the quick 60-second elevator speech on what's the value of this, right? So there are three key drivers, right, for our EcoStruxure advisory services to really create impact for our customers. So number one, detection of abnormal conditions. If you don't know this, 59% of critical events, fires, and other events related to electrical equipment happen because of just electrical fires and because of lack of maintenance, lack of the correct procedures. 55% of people continue to do maintenance either in a reactive way, meaning we're really not doing maintenance, we're just reacting to something that happens, or a mix of that reactive and what people call preventive, calendar-based, which a lot of people in other industries call it predictive. And then about a piece of equipment could lose half its lifespan if it's not operating in the correct conditions and the correct loading and the correct operational settings, right? So we're acceleratedly aging a piece of equipment, right? Now, coming back a little bit into my middle point, right? If we study a little bit into what's called reliability center maintenance, right? And this document that I'm referencing here, the DOA operations and maintenance best practices, it touches on the concept of the typical bathtub curve, right? So a lot of failures happen at the beginning, manufacturing, warranty kind of issues, right? Once the asset stabilizes, you hit the bottom part of the bathtub curve, where most majority of the failures happen because you are either over maintaining the equipment or under maintaining the equipment, right? And then on the third, let's say on the upside curve of the bathtub, the failures happen because the equipment is old, right? The equipment is already at the end of its lifespan, so there are components that are more prone to failing, and so the failures that you see there is because the equipment was just old, right? It's natural aging of the equipment. You already realize its full potential, and so you start seeing more of those failures, components failing, etc. Right? So this applies to a variety of different things. So really, what we want to see here, and how we help our customers, is improve their maintenance operations by correctly helping our customers maintain their equipment at the correct time, in the correct moment. And so we have different examples that we could talk about to exemplify this tree. We've helped different customers in different industries achieve these three outcomes, right? So I'm gonna go here into the first one. And so this first one is the case of a customer that is on the foundry side of the business, so industrial applications, right? They actually were on Twitter for the wrong reasons, bad PR, a bit of a PR scandal there. I'm omitting their name for obvious reasons and privacy of their organization, but we held them, right? So what do we do? So by the means of technology, so sensor applications, we were monitoring a piece of medium voltage equipment that they had already had 2 incidents where this equipment had an explosion. It's obviously a safety risk, right, for the personnel in the facility working there. And so by the means of sensing technology and analytics, right, we were able to detect that at certain points during the day and at certain times during the year, they were having condensation presence inside of the equipment. So basically, outside it was too hot or too cold. Inside of the equipment, it was probably too hot. So you have that rainforest effect, same thing that you get in your car, right, in the mornings when it was very cold during the night, and then all of a sudden it starts getting warming up in the morning, right? And so they have the presence of enough condensation that it was going to create another explosion. So by the time we started helping this customer, and they told us, hey, we have a problem, we can put a finger on what this is. We instrumented this transformer, we started pumping data to the cloud around the sensors, the meter monitoring this medium voltage switch. And so at some point we said, yeah, our dew point presence or dew point condensation presence algorithm has detected that at this rate of temperature, humidity, etc., you have a significant risk of actually having enough condensation inside of the equipment that will cause a problem, right? So that's a great, that's a good, right? We know that there's going to be an issue. We know there's going to be a problem in this piece of equipment. Why is this happening, right? Why is this happening actually for the 3rd time? So here's where we go into what we call the prescriptive recommendations, right? And this is where the human element, the human touch is necessary, right? Because the data is telling us something, but now we need to contextualize that data and really figure out what's the root cause, right? So our service is a service where we have consultants that are helping our customers understand that root cause, right? So our consultants get engaged with this particular customer, and we start asking for drawings, and we start asking for more documentation. And so we notice different things. In the design of this outdoor switch, right, they should have put a fuse, right, in order to turn on the heater. Well, the fuse was missing on the drawing, so we had to go and check if there was a fuse there. Well, it happens that there was a fuse, right? Someone had the idea, hey, there's a fuse missing here, so they put on the fuse. Now, number 2 is the thermostat set in the correct settings so that the heater in this outdoor switch, in this piece of equipment, is properly turning on to turn the heat on, to lower the humidity levels so that condensation is not happening. Or maybe it's too hot, and that's why condensation is happening. So is it on the right settings, right? Well, it looks like it is. It is the right settings for the temperature and also for the humidity, right? Because this thermostat controls both, but it turns on the heater both in terms of in the presence of high humidity or in the presence of low temperature, right? So okay, so it is turning on correctly. Okay, so what's happening here? If there is a heater there, and in the thermostat with the humidity and all that is in the correct settings, the fuse is there, what's going on? So our engineers, our consulting team that are part of this service, this digital service we're delivering for the customer, they take a look at the drawings and they say, aha. So this switch was shipped without a humidistat. Basically, that humidistat is like a little sensor that ships with this type of equipment that is supposed to turn on the heater when humidity levels start rising, right? Well, we talked to the manufacturer of this particular switch, right? And which name of the manufacturer I'm also going to not mention here. And so we go and talk to the manufacturer. We start like digging on this, and it turns out that for this particular part of the country, they don't ship the switches with a humidistat because traditionally, historically, humidity has not been a problem here. But call it global warming, call it climate change, however you want to call it. For a few years now, humidity levels have been on the rise, right? And so now humidity levels, temperature swings in different times of the year are creating a problem. And so we got to the root cause of this issue by not only the means of the technology, but also the means of understanding how this piece of equipment was put together, that human consultation, the human interaction with the customer. And now the customer, when they understand the problem, now they're able to issue a work order, issue purchase orders to fix the problem at the root, right? Where it really started. So again, this is a case of a customer where we were able to prevent a third critical event, critical failure that was about to happen there. Now, number two, this is a case of one of our customers in the food and beverage space. Okay, so manufacturing plant, where this is what you see in the first column is the standard maintenance that they had on their processes, right? So their standard was to provide a maintenance to these medium voltage circuit breakers every 3 years, low voltage breakers every 2 years, and they have some variable speed drives to maintain every 2 years, right? Well, through the means of data historization, because that's really what we're doing at the very basic level here. So by the means of data historization, being able to accurately assess the condition in which the assets are operating in terms of environmental conditions, loading conditions over time, operation conditions. So has the breaker open and closed, for example, how many times and how many amps, right, is this breaker open and closed? If it was a back trip, right, under a lot of load, then it might have damaged some part inside of the breaker. So we need to maintain, or we need to inspect the breaker at the very least, right? So understanding that historization of the data, contextualizing that data, right, and having that discussion with the customer, we're able to advise, right? We're able to say, okay, so your medium voltage breakers, they've been running on a load of like 30%. The environmental conditions under which they're operating, humidity, temperature is controlled, right? Salinity is not a factor. You open and close your breaker in the last year, so you've tested the breaker, the mechanism is fine. So if these conditions persist, these are favorable conditions, right? So we have 4 categories: favorable, normal, severe conditions, or intermediate conditions and severe conditions. So we've spent 90% of our time on favorable conditions. We're able to say, if these conditions persist and we continue to operate the breaker in this way, we could maintain that breaker, extend that maintenance from 3 years to 6 years. On the low voltage breakers, you could go from 2 years to 4 years. Continue to inspect, right? So continue to do just regular, let's say level 1 inspections, right? Continue to monitor, continue to see that the conditions have not changed. But in the case of the variable speed drives, right, it changed. They had an event, the drive started giving us some failure and faults, and so they had many starts and stops that were unusual. So in that case, the data that we were aggregating, the points that we're monitoring, are suggesting that these drives will actually require maintenance in the next 6 months to avoid a critical failure, right? So this is all good and great. And you may be able to say, okay, yeah, but that is not a standard, right? Like, this is not the standard way of doing things. Well, there's some good news here. So if you're familiar with NFPA 70B, right? So NFPA 70B at a high level, right? It is getting revised, right? It was a standard that was adopted in 1975, revised regularly. Currently, we're running on the 2019 edition, right? There is a technical committee that reviews this NFPA standard. It has 41 members, and it's a good balance between manufacturers, users, contractors, DOE, the Department of Energy, national labs, right? Insurance, inspectors, NIDA, blah, 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 right? And so basically, the current recommendation, the current recommended practice that is changing on NFPA 70B, right, is that we're changing recommended practices for monitoring and predictive technologies, right, to a mandatory language. It was not even in the standard before, right? And now it's transitioning to mandatory language for condition monitoring and predictive monitoring, meaning there's a difference between condition monitoring and predictive technologies, right? So now that language of continuous monitoring and predictive techniques is part of the mandatory language in NFPA 70B, right? Both of these, with that shall the user or the operator shall use continuous monitoring and predictive techniques, it's going to be included in the 2023 revision of the document, right? Both, or rather, all the parties that are part of this committee are widely supporting the inclusion of this language into the revision of NFPA 70B. And so this is something that is coming, and this is something that will now validate and enable, right, things like what I'm presenting here, right? So this is just a change that we're seeing. Like I said, Schneider is particularly already helping customers walk this path. And so this is just an example of one of our customers in the food and beverage space where we've helped them with this, right? Now, how else have we helped customers with, for example, accelerated aging process? So this is a quick story, also with a customer in this case, again, the food and beverage space, where I'm going to just tell you a story. So they have a transformer, dry type transformer that was presenting elevated temperatures, ambient condition temperatures, and also humidity, high humidity, because of the place where they're located. And so basically, at first, we told the customer, hey, these conditions on the transformer externally, so the ambient temperature, ambient humidity conditions, but also sensors that are helping us detect the presence of hotspots continuously. It's continuous thermal monitoring, right, installed on these transformers. It's also suggesting that you have some elevated temperatures there. Customer said, no, I don't think that's happening. We went and we inspected the transformer from the outside. There's no humming, like we're humming on the transformer. That was basically the way of evaluating it. And so we think it's okay. But then we said, okay, look, our algorithm, our analysis, right, in our predictive platform is telling us that under these conditions, this transformer could be losing between 2 months and 2 years of its remaining lifetime during the following year, right? And the importance here is we purchase electrical equipment thinking, think about transformer, a breaker, I'm making an investment that should take me, well maintained under good operation, should take me to 25, 30 years, 35 years, or some customers there to go even further than that, right, without replacing it, right? I'm going to maintain it the right way, and it should last what the manufacturer is telling me it's going to last, right? Well, the story here is there are standards, IEC and ANSI standards that tell us that if a piece of equipment, breaker, transformer, or else, right, is operating under non-ideal conditions, or rather adverse conditions, components of that piece of equipment accelerate in a more, or age in a more accelerated way. And so this was the case of this particular transformer, right? So we advised the customer of taking different actions. So we said, hey, you might want to go and check that some of these forced ventilation fans are operating to lower the temperature on the transformer, given that the temperature in your substation, you can't really lower it because of how you design the substation. That's a much larger investment. That's a much bigger problem to solve. So let's go and check that your fans at least are working, okay? So we're gonna check that. Number two, let's do some individual harmonic analysis to make sure that also the heating up of the transformer itself is not coming from high harmonics, right? So that there goes also the necessity to also implement technologies like, for example, energy management and power management monitoring, right? So basically an electrical SCADA system, right? And so they had that. So they went to the electrical SCADA system. They started looking at the harmonics. No, there's no harmonics in the system. It should be fine. And so finally, while they're implementing all these recommendations and they're doing this investigation along with us, right? So we are the eye in the sky. We're consulting remotely, right? So we're telling them based on data and based on our platform what we're seeing, based on knowledge of the equipment, what the problem could be. But they are on the ground. The customer is boots on the ground, okay, grabbing all this data and doing this assessment, right? So at some point, then we see that the situation at the cable connections, right, basically where the cables connected the log of the transformer, the situation there is starting to degrade faster, right? So we say, hey, things have turned a little bit of a turn for the worst. There's something that's happening there. You need to go and check it out. Customer said, I don't think so. I went there. I shoot my IR scan on the cable. I don't see anything going on there. We push the customer. Customer says, okay, I'm going to go and take a look. I'm going to disconnect the transformer, but I'm not happy with this because I'm going to have to shut down production. But I'm going to listen to you, right? So then they go and listen to us. And when they disconnect the cable, if you see the cable here in the back end, there's no damage, right? Here, and this is primarily, this is where they shoot their scan, right? But then the cable, right when it connects, right, to the log, then you can see that the individual conductors were already starting to melt. And this is what we detected with our sensor, right? Now, what our platform did is it correlated the temperature there, where we had our sensor monitoring this, with the load on the transformer, with the ambient conditions, right? And so the ambient conditions were a little out of whack because the temperature was really high. It was 120 degrees Fahrenheit inside of this substation. And so, so we really had to discriminate. Is this really a hotspot happening, or is it just a natural increase because of the conditions under which this substation is operating? So in the end, the algorithm told us, no, there's a high probability here that this is actually a hotspot. You should check it out right now. So they went, they did that. And so this customer in particular had already had a hotspot in this same substation on a breaker before they deployed predictive technologies. And so we knew exactly how much this shutdown was going to cost them, right? So there is a business case there that was made really quickly, right? So with that, what we really realize here in these three particular cases, right, is that there are three different return on investment paths, or three different return on investment timelines, right? So, and I will cap it off with these for examples. So when we think about digital technologies, everyone starts saying, oh, I want to see return on investment for deploying sensors and software and analytics, and I really want to see the return on investment. And I think we miss the point in a lot of these many times. Return on investment, usually we go and we focus on the asset abnormal conditions piece, right? I will see my return on investment when something was about to fail and it didn't fail, so therefore I can make my math very simply. Okay, this equipment was $80,000. The whole cleanup to get it out and check the equipment that might have been damaged by this explosion or this fire, it's another $100,000. And then my production or my hospital went down, and so it's a PR nightmare. And patients, might have died on tables. So a lot of lawsuits happening here now. And so you start making those numbers, and it's like, oh yeah, look, you detected this hotspot that was about to happen, and it really saved me $30 million or more, right? It's very easy to make that math, right? And then people get hung up on that one point. But then we miss the other 2 points, right? Which is medium term, right? If you are able to tell me that I don't have to maintain all 30 breakers and 5 transformers in my infrastructure, to say a number, right? You're telling me that next year I can spend my maintenance time focused on these 3 pieces of infrastructure that are actually suffering from some sort of health issue, right? And the other ones I can defer another year or another 6 months. Then you're increasing my uptime and you're reducing my OPEX for maintenance, right? Or at the very least you're deferring it, right? So that's a medium-term play, and that's something that we're only able to understand, like I said, after the data historization of how you're utilizing your equipment 12, 14 months, right? And then the long-term play, right? Which is, again, I invested on this equipment, top-notch, right? I paid a lot of money for it to get it going. It was a $1 million investment in this new substation, refreshing of my equipment, right? And will this equipment take me 30 years into the future? Or is there a condition, operational, environmental, or whatever else, that means that I'm going to have to replace this equipment, or I'm going to have to do significant maintenance or replacement of parts starting at year 20, when this shouldn't have started until year 27 or 28, right? So how do we make sure that this equipment, that we understand the aging process of the equipment, that it will take me where it needs to take me, right? And so when we evaluate predictive digital technologies, they have to be evaluated in the correct timeline light. Let's put it that way, right? And so this is something that, again, Schneider has been doing with a number of customers. There is a very famous case. If you look it up, I know I'm talking about different industries here, but if you look it up, there's a very famous case on YouTube. University of Rochester Medical Center is probably one of the 2 customers in healthcare that allows us to use their name, because they've had several of these. They had a case where we detected an issue with a transformer, very similar to the last case that I was presenting. They dragged their feet to understand information, to really take action on what we were telling them. They ordered a transformer. The transformer takes a long time to get there. and 3 or 4 days before the transformer is supposed to be installed, the other transformer blows up. So, like I said, there are different cases. That's one particular case that is famous, is out there, it's public, right? So you can look at it. There's a use case and a white paper that we wrote about it along with them, with URMC. If you want more information about that, I'm happy to provide it later on. Now, let's bring this down to earth a little bit, right? So from concept to real life. And with this, we're approaching the end, right? So we have our technology has a triaxial delivery model, if you will, right? So what is that triaxial delivery model? Well, what is the asset breadth? What do we cover with this particular offer, with this particular solution, right? So we cover dry type transformers, oil transformers, medium voltage switchgear, low voltage switchgear, automatic transfer schemes, variable speed drives, rotating equipment, so motors, pumps, conveyors, kind of thing, UPSs, and then also, of course, your electrical network by the means of the correct software, right, that allows us to also do analytics on the power system, right? And then instrumentation. And what you see here are the 2 types of sensors that we particularly use for continuous thermal monitoring on circuit breakers, cable connections, transformers, etc., right? Great technology, used on its own just for continuous thermal monitoring. Great. You want to really amplify that and really get the bang for your buck, add the analytics to it, right? Now, that's the asset breadth. That's everything that we can cover. So as you can see, it's all electrical distribution technologies, right? Now, how do we do it? That's the offer depth. That's the part behind the curtain that you don't see every day. So that is, I mentioned some of these words, through data historization, machine learning, data analytics, artificial intelligence, and then of course, always, and this is part of the delivery model that I'm going to present to you right now, it's also the human interaction. Data without context, without human interaction, artificial intelligence is not there. It's not there to provide that human context, human expertise that we have today. To a certain degree, it could, but it's always human driven, right? It's always still with the human, with the human touch. Let's put it that way. Now, one thing that I want to also show you, so when we're able to combine the analytics for asset management, so what I'm saying is what I was presenting. So do I understand the health of this particular circuit breaker or this particular transformer? When we combine that also with the monitoring of the electrical network, then it becomes very powerful, right? And so this is the other solution that we have. The other solution that we have is that monitoring of the electrical network. And so think about it this way: we have analytics for and machine learning for the analysis of the electrical network, power quality, harmonic presence, sacks and swells, and all of that. How is that affecting, right, your electrical network, your highway, right? So through the means of the software and the analytics for the software, we're monitoring that electrical highway of your infrastructure. But then that highway, if it has electrical potholes, is going to have an effect on your electrical equipment. So this is something that we saw with a particular customer where, like I mentioned before, one breaker was heating up, but it was not heating up because there was a loose connection on the breaker. It was heating up because there was harmonics on the system, right? And so the root cause was not the breaker, the root cause was the harmonics on the system. So when you combine the monitoring of your electrical network and the analytics of that with the monitoring your electrical equipment, you really can hone in into what is really causing the problem, right? What is the root cause? And so to use a very simple example, right? We monitor both the electrical highway and the quality of that electrical highway, as well as the assets that are riding that highway, right? And what is the health of that asset? A car can fail because it falls into a pothole and it screws up your suspension, or it can fail because there is a defect in the motor. So we want to provide that deep understanding of exactly what's the problem, right? And now the delivery model, how do you interact with this data? How do you see it? How do you receive this service, right? And this is where we're going a little bit into what I explained at the beginning. So you have technology, you have a dashboard where you can see your assets, you can see a matrix that you can barely see here in a very small size, that tells you immediately, okay, you have these many assets that are in good health, these many assets or equipment that is in bad health. So your focus should really be on the equipment that is in poor health, right? Then I'm not there. And this is the case, I also have it somewhere else, of a particular customer here in Texas. So you also have access to a mobile application that gives you access to all that same information. And here is one more example. When the Texas freeze happened in 2019, I had this customer who supports multiple sites across Texas, right? Multiple facilities. And so he is spending a week over in Beaumont, over in Louisiana, right? And he has one facility in Beaumont, Texas, that was particularly affected by the Texas freeze, right? And so he pops out his dashboard, he looks at his phone, and he has an alert. Oh, these two UPSs have a health alert, right? Something was happening with these two UPSs. He's in Louisiana, the freeze is happening, he can't come back to support his people on the ground. So he grabs the phone, he grabs the dashboard, and then he also calls the consulting engineers that are helping monitor his sites on the Schneider side, right? So he calls his consulting engineer and he's like, hey, I'm seeing this behavior. I got this notification. Consulting engineer is like, yep, I was looking at it already. I also see it. We were preparing a report for you. Give me 1 more hour. We'll give you some ideas on how to resolve this. They connect 1 hour later and they say, okay, this is what you can do. They connect with the guys that are on the facility. They say, hey, we will receive a notification, right? There was something not heading the right direction, right? We have probably a couple of days to fix this. So these are the steps you're going to take. I can't be there, said the guy in Louisiana. The Texas freeze is happening. Roads are not safe. So from here, I'm able to see all the information, all the electrical information, the sensor information, everything is happening with the UPS. So please go and fix it. I'll support you remotely. In the end, what happened is everything was fixed. And then our consulting team, they created a report that outlined what was detected, how it was detected, what was the resolution implemented, and what should we do as next steps, right? And so those reports that we deliver for our customers are both incident reports. We shouldn't really call them incident, but that's how they're called. So incident reports where we detect something, we let you know, we fix it, we catch it before it gets into a critical state, and now it's an actual event, right? And then we call them also the periodic reports. And so those periodic reports are more on the proactive side. So every quarter, our online consulting team, our remote monitoring center, they sit down with our customers that we're monitoring, and they say, okay, look, this is an analysis of your infrastructure. Here's your breakers you're monitoring, your transformers, your UPSs, your motors. Everything looks in good shape. Or no, this variable speed drive is a concern. We're seeing this behavior is deviating from our expected model of behavior for drives. You should really go and check it out. Here are some recommendations on what you can do, right? And so those periodic reports are more, like I said, on the proactive side. And then the incident reports, quote unquote, is some failure is rapidly accelerating, is rapidly deviating from that model of expected behavior. And so you need to take action now, right? In order to prevent this from happening. So, like I said, in the beginning, wrapping it up a little bit with what I mentioned in my first slide, is not only about the technology that we deliver, but it's also how our team is helping your teams contextualize that information, understand it, and then be able to internally, you yourselves with your internal teams, or your contractor that you bring, or if a Schneider is doing your maintenance, like bring the right people on the ground to be able to take the necessary actions so that you prevent something from happening, so that you improve your maintenance, etc., so that you improve the aging process of your equipment so it lasts what it's supposed to last. So we want to also help you drive those actions, right? It's not that we're taking your place, it's not that we're taking your job, that's why we're advisors. We're advising you on what to do. You take the actions, you make the decisions, you're in control, but with data in hand, which is the big difference that we have today, right? You have data to really understand why you need to take an action, right? And so with that, now we move into a little bit more into just a high level overview, right? So what do we deliver? If I were to show you like a standard architecture for this service, is you have equipment, so transformers, breakers, drives, UPSs, thermal monitoring, sensors, gadgets that we deliver for you. You want to connect them to be able to consolidate all the data, whether it is on an EPMS system or an energy management or electrical SCADA, however you want to call it. You want to consolidate that data in a central repository. If you don't have that central repository, there are IoT gateways that help us concentrate and gather that information. We want to collect that information that helps us make critical business decisions. We take it to our advisory services. We analyze it through the means that I show you of machine learning, analytics, also the human analysis and interaction and contextualization of the data. We notify you in case we need to notify you about something. We allow you to visualize the data like I show you through the dashboards, through your phone application. And then we discuss with you in those consultations, right, to take action. Yeah, so we want you to take action out of the data you're receiving. And so basically in those consultations that we made you help, like it says, we made you help make business logic or business sense of the data that you're receiving. And ultimately what we want to do is, like I said, drive those actions, right? And so with that, that's the end of the presentation. And so we have 9 minutes to spare for questions, if there are any questions there in the chat. And here you will see some of the logos or the names, right, that have done, or we have deep partnerships with them because of the results and the outcomes that we have delivered for them, right? The really business monetary outcomes, right, that we have delivered for these customers. Like I said, different segments, right? Chemical industry, food and beverage industry, high-end hotels, which is on the hotel industry. And like I mentioned, I should also put the link there to the URMC business case. But yeah, and so with that, I thank you for your time, and I hope this was worth your while. And if there are any questions, I'll let Amy. Amy, I don't know if you've been monitoring the chat, but if there are any questions, I'm happy to spend the next 7-8 minutes answering questions.
Yeah, absolutely. We got two here. So first is, what protocol is used to send the information? I think you might have just touched on that, but do you want to explain a little more? The follow-up is, are we able to grab this information directly from PLC HMI over TCP, IP, Ethernet, etc.?
Yes. So the standard protocol that we're using is Modbus. I think that's probably one of the most common open protocols out there, right? But we have customers who have, for example, protection relays who are using 6150. We have some customers that are using, for example, Profinet or BACnet if it's a building. So we might not be able to directly take the data or the information on BACnet, but we use, depending on the architecture. So I'm going to go a little bit into the weeds here. But if you have the means of an electrical power management system or electrical SCADA, typically you could take different protocols into that, and we just grab the raw data that we need. If you don't have that, then we might have to convert that data to something like MP3 or Modbus, something more open. But yeah, the standard would be Modbus. So your sensors, your relays, your drive is stuck in Modbus or something similar. Like I said, Modbus, MP3, 6150, all of those we should be able to take directly, right?
Okay. And then, is there any way to isolate this technology from a web connection in order to gather the info and make decisions internally?
Can you repeat the first part of the question? Because I don't think I caught the critical part of it.
Is there any way to isolate this technology from a web connection in order to gather this info and make decisions internally?
So not for everything. We have certain basic analysis that you can do, and this is because of the processing power as well, and the improvement, or the continuous improvement on the analytics that we do, right? And I think I have to answer that question, 2 points in that question. So number one is, so for example, for breakers on our electrical SCADA system, which is called Power Monitoring Expert, we have something that is called the breaker performance module. And so the breaker performance module can give you some information, particularly on breakers, right? And we're working on embedding something similar right there for example, dry type transformers. But the reality is there is a reason why we have this on the cloud. And the reason we have this on the cloud, and this is probably the reason that it's a reason, it's also a benefit for our customers, right? A couple of times a year, what we do is we continue to revise the models, right? And so the models are revised in 2 ways. So number one, so all the data from all our customers goes into a data lake, right? So that data lake anonymizes the information. And so your breaker, your transformer, your motor is compared against similar breakers from different manufacturers or for the same manufacturer. And so we're able to identify failures easier by being able to do that, right? That kind of processing power is difficult to just bring down to the edge or to on-premise, right? And that capacity, that also gives us the capacity to improve the analytics. So if you were a customer of ours, a couple of times a year, usually the guys that are in charge of the analytics, they release a letter that is saying, hey, in the last 6 months, we did an improvement on transformer analytics, motor analytics, breaker analytics. Here's what we did. These are the changes that you're going to see now. So now you have, for example, a fire risk index that is telling you now percentage of fire risk at which you are, right? And so those are free of charge. So this is all like Office 365, so it's a subscription, right? It's software as a service, right? Basically, but it has the benefit. It has the benefit that you really are not paying anything extra for that continuous improvement of the analytics and that continuous improvement of how we're comparing your data or the data of your asset against other assets data. And so that's for free. I deal a lot with customers who have on-premise software, and it is a headache to say, hey, my software is 5 years old, the new version is coming out, now it's $20,000 to be able to upgrade the software to the latest version. I have to shut my plan down. It is a risk to have the HMI on while we're doing this migration. So it has its nuances, right? So this eliminates that piece as well. Now, the second part that I'm going to answer, which was not necessarily the question, but I think it might be the reason behind the question, is the cybersecurity portion, right? Typically, when people ask me this question, is because the concern is cybersecurity, right? And I could go on and on everything that Schneider is doing around cybersecurity, but I'm going to leave it in 2 points. Number one is every single time for the last 7 years that I've been working with this particular offer that we've developed for cloud services, every single time, 10 out of 10, when I tell a customer, hey, we have a system that is using cloud services, the first answer is no. No, we don't do cloud. We're adverse to the cloud. We don't do it. 9 out of those 10 times, the customer has ended up being connected. We found a way to negotiate and to really find a secure path and a secure way to make this a reality for them, right? So the short answer to that question or to that concern is, look, usually the people operating the equipment, the people maintaining the equipment, the people on the upside are not the correct people to make those decisions. So usually what we do is, hey, if you see the value of how this can help you improve your business, just get in touch with your IT person, right? And let's have your IT or OT department have a discussion with our cybersecurity people, and we'll find a way to make it happen, right? We have a couple of standard ways to take that data to the cloud, but more often than you would think, we've actually deviated from those 2 standard ways to accommodate a way to make that happen, to make that connection happen and deliver you the value that this can deliver to you. So that's the 60 or 75-second answer to that piece. And again, I could go 2 hours, introducing how we do this in a cybersecure way, but I'm going to leave it at that for now.
No, I think that's huge. I think one of the biggest pushbacks we see when we're talking to facilities is from the IT department. So bringing them into the initial conversation, I think, is huge, and we can usually combat that pretty quickly.
Absolutely.
Well, great.
And we're very used to that, by the way. So anyway.
Well, great. Thank you, Alfredo and Amy, for the presentation. We're coming up just at the top of the hour here. Any final thoughts for our audience?
Yes, I was just going to do a quick summary. I mean, we know, we hear reliability-centered maintenance is a huge topic in the healthcare industry. So increasing uptime while decreasing OpEx, all while prolonging the life cycle of your equipment is really key to, an efficient and reliable healthcare facility. So with that focus on asset lifecycle optimization and the prevention of critical events like Alfredo detailed out, we want to provide that holistic approach with AI, but that keeps that human interaction at the core approach. So we at Schneider Electric have a huge focus on safety, sustainability, and innovation. So all the themes that Alfredo outlined today, are very close to home, and we appreciate you joining us on the journey today. Alfredo, any final words?
No, just thank you so much for your time, and thank you for sticking out with us. And have a good day. Happy Thanksgiving.
Great. And as a reminder to the audience, you're going to receive a link to a brief online assessment tomorrow. And when you complete this assessment, you're going to receive a CEU certificate. And if you'd like to rewatch it, it will be archived at healthcarefacilitiestoday.com/webcast. Again, thanks for joining us today, and this concludes the webcast.